Now we're going to get into secondary ties. Now notice when we review this figure 20-15 from Stallcup's design book, volume 2, reviewing 20-15, and you wouldn't really, I don't guess, be interested in purchasing a copy of our design book without you really dealt with large facilities, plants, industrial plants, and things that have these kind of systems. But notice in the illustration, we have a 2000 kVA transformer. We have a 1500 kVA transformer. But let's focus on the 2000 kVA transformer, three-phase, 480 volt. And notice that transformer power is routed to the bus in the switch gear where you would have your CBs. You have one CB, to the tie system where you'd have maybe even other transformers tied in so you'd never go down. And in the 15 kVA, you have a main fed going to the tie system. Then you have your circuit breakers there that deal with the secondary tie across here. And we're going to kind of deal with these loads that these transformers could feed through this. Now notice the overcurrent protection device, CBs that you see. Notice we have these current limiters installed at 67% of the secondary amps of the largest transformer to give the additional protection that's needed due to, say, short circuit, ground faults, overloads, and things like that. And notice in the step one now, we determined the output of the transformer by finding the full load amps of the 2000 kVA transformer. FLA is equal to kVA times 1,000 to get it into the volt amps, divided by the voltage times the square root of 3. So we'll have 2,000 times 1,000 divided by 480 volt times the square root of 3, 1.732. And when we perform the math, we come up with 2,406.7 amps. And that could be rounded up to 2,407 if you wanted to. Now, to calculate the 67% rule, step 2 takes 450.6A1, 2,406.7 times 67%, we come up with 1,612.5 amp. Rounding that up to the next size bus tie, it would be approximately 2,000 amps. So that would be the bus tie that you see here, from transformer to transformer and to switchgear bus with its limiters there. And then you see the size that it would be calculated. So this figure 20-15 is basically illustrating how to determine the ampacity of the ties connecting the conductors. These ties shall not be less than 67% of the rated secondary current of the largest transformer in the circuit, and that's what our figure 20-15 is illustrating.